Hi, I'm Jason. Welcome to this section of the Pre-Algebra Tutor. Here we're going to continue on and we're going to learn how to divide expressions, how to simplify expressions that involve division. Now, as you know, division, fractions I should say, are really division in disguise. So a lot of these things are going to be giant fractions with variables on the top and variables on the bottom. So that's what I was going to say as far as earlier when we spent so much time with fractions. It's because all of these algebra expressions and later on equations are going to always involve fractions of some kind. So knowing and being really comfortable with fractions in general is going to really help you here, and that's why we did so much material with that. Let me give you a little bit of a roadmap where we're going. We've done adding and subtracting expressions, how to combine terms and so on. We did multiplying expressions, which is you run into a lot. Now we're going to do a dividing expression, so we're just giving you more experience with how to handle these algebra things when they're put together in different ways. Next section, we're going to solve our first equations. And so we're going to use all of the skills that we've been using up till now in order to do that. So everything is building. Now, before we get to actually dividing these guys, I want you to recall a few things. These are things that you already know, but that you might, need to be reminded of. So, as an example, x cubed, remember we talked about this before, divided by x. There's two ways to think about what to do here, depending on the book you have. One way to think about it is, well, you just take and subtract the exponents. 3 minus 1 is 2. So you'll have x squared. 3 minus 1 is what you're doing. You're subtracting the exponents there. Another way to think about it is sort of the way I was talking about more recently in a couple sections ago. If you have something like x cubed over x, you can sort of think about this fraction has some x's in the top and some x's in the bottom. So because they're kind of common, I can cancel this x and I can cancel one of the x's on the top, leaving behind 2 on the top. So that's going to be x squared. Now, whatever way you prefer to think about it is fine. I think this is a good way to learn it in the beginning, just subtracting the exponents. But more practically, when you start dealing with these expressions, you have some x's on the top, some x's on the bottom, some y's on the top, some y's on the bottom. You're going to be canceling all the time. So it's probably more practical to think about it in terms of this. And so we're going to get a lot of practice with that. Second thing I want you to recall, I guess, or should just to think about, is if I give you something like x plus y over, well, it doesn't matter, z, you can bust this fraction up. See, this is a fraction with something added together in the top, and then you have a denominator. You can bust this up to be x over z plus y over z. The only reason I bring this up is because some of these problems here, you're going to need to do this, and some students are like, well, how did you do that? Well, think about it. If I didn't give you the answer, just cover your hands up here, and you just looked at this, how would you add those fractions? Well, you would keep the common denominator, and then you would add the numerators. Well, that's exactly what I gave you. I kept the common denominator, you add the numerators. So this is no different than what you already know. I'm just going in reverse. If you're given this, you know how to add them together. If you see something like this, where you have something plus something and then you have something on the bottom, you can bust them apart. And this applies to numbers as well. If you have 3/5, let's say, you can write that as 2 plus 1 over 5, because 2 plus 1 is 3. So you can write that as 2/5 plus 1/5. So going backwards may seem a little strange to you, like how did he do that? But think about it. If I cover this up and say, how do you add these fractions? You would keep the same denominator, you would add the numerators. You would keep the same denominator, you would add these numerators together. So all I'm saying is that when you have a fraction written like this, you can bust it up. It's going basically backwards from what you've done before. It's very, very handy when you're simplifying these guys. So let's do our first problem. What if you have something simple, x over x? Now again, there's two ways to think about this. One is, well, I have x to the first power on the top and x to the first power on the bottom, so I can basically say x, 1 minus 1. Subtracting the exponents is going to give me x to the 0 power. Anything to the 0 power by definition is a number 1, so the answer is 1. But another way to think about it, the way I sort of prefer to think about it, is when you're looking at something like x over x, this is like 3 over 3 or 4 over 4, whatever. You can sort of cancel the top and the bottom, leaving just simply 1. You don't have to subtract any exponents. You're just basically noting how many of these you have in the top and how many you have in the bottom. You're canceling what you have common, and you're left with 1. Let's go ahead and work a few more and see if you get the hang of this. What if you have 2x over 3x? Now, it doesn't have any bearing at all that it's negative. That has nothing to do with it. But we notice we have an x on the top and an x on the bottom, so I can cancel the x on the top with the one on the bottom, leaving me with just negative 2/3, and that's the answer. And this is dividing, this is division going on here. We've kind of done this before with this cancellation stuff. We did it when we were dividing fractions and multiplying fractions, and we're doing it here. Now, what if we have 6x cubed over 4x? So let's look at the variables first. We have one x down here, but we have x cubed up here. So we can cancel one of these x's with only one of them from the top. So I'm going to change this exponent to a 2. Because remember, this was x times x times x originally. When I cancel one of them, I just have x times x. So that's x squared there. So I'm done with that. Now let's look at the numbers. You can simplify this. You can divide this by 2, giving you 2. You can divide this by 2, giving you 3. And so ultimately you'll have 3x squared over 2. 3x squared over 2. Looks a little bit ugly with all these cancellations, but as you do more problems, you will get the hang of it, and it won't quite seem so ugly. Now what if you have x to the 7th power over 4x to the 5th power? So we notice we have x to the 7th of here, so we have sort of 7 x's multiplied together. We have 5 down here. So I can cancel all 5 of them, and I'm going to be left with only 2 in the top. So what you'll have is x squared over only 4 on the bottom, because all of the x's are now gone. So I'll have x squared over 4. Now here's where we get into that fractional thing I was telling you about. 12x minus 4 over 4. How do you handle that? At first you might not know what to do because you can't really add these terms, you can't really do anything, but you can always, if you get stuck, split a fraction up. So we can split this up as 12x over 4, and then we can split this up minus 4 over 4. And the reason we can do that is because if you cover this up, these have a common denominator. So you would keep the common denominator, you would add these numerators, which comes out to that. That makes total sense. Now that you have it split up, 4 is going to cancel with 4. That's going to give you 1 there. And here, you can divide this by 4. You can divide this by 4. That's going to give you 3. So ultimately, you're going to have 3x, right, over 1, but that's not going to really matter, minus, and then this comes out to 1 also. So you have 3x minus 1. 3x minus 1. So it really boils down to you splitting things apart if you can, and just looking for common things in the top and in the bottom, and just make sure that you're following the rules. So let's take it step by step. That's why we're taking sort of a logical progression of problems. Negative 12x plus 3 over 3. So again, you can't do anything in the top, you can't do anything in the bottom, but we can split it up. So we'll say negative 12x over 3 plus 3 over 3. Just busting the problem up. We're going to have sort of the same thing going on. 3 is going to cancel like that. And this guy, we're going to divide the bottom by 3. It's going to give me 1. We're going to divide this by 3. It's going to give me 4. So ultimately, I'm going to have negative 4x over 1. So I'm going to not put it there. Plus 1. Negative 4x plus 1. Okay. Now what if we have negative 8x squared plus 6x over negative 2. So let's bust this fraction up. I'm going to have negative 8x squared over negative 2, taking this guy here, plus 6x over negative 2. I'll keep the same denominator there. So I'm going to do the same thing, working over here. I can divide by negative 2. So I can strike that out. When I divide 6 by negative 2, I get negative 3. Here I divide by negative 2. When I divide negative 8 by negative 2, I get positive 4. So I have 4x squared minus 3x. Don't forget your x. There's nothing in the bottom because I've canceled it all out. So I have 4x squared minus 3x. All right, moving on along. Let's work a little bit longer problem, not too much longer. What if I have negative 15a squared plus 6a over 3. And so I split this guy up, and I say, okay, I have negative 15a squared over 3 plus this guy, 6a over 3. I'm just doing the same thing over and over again. And then when I look for cancellations, I have 6 and 3, so I'm going to divide by 3. I'm going to divide this by 3, that's going to give me 2. That's a little bit hard to read, so I'll use red on the next one. I can divide this by 3, that's going to get rid of him. I can divide this by 3, that's going to give me 3 times 5 gives me 15. So ultimately, I will have negative 5a squared plus 2 times a. Negative 5a squared plus 2 times a. So sometimes splitting these things up can really make a world of difference. Now, what if we have something a little bit bigger? Let's say I have 12x cubed plus 15x squared plus 9x, all divided by 3x. So you see the same exact thing applies. Here I have 3 terms on the top of my fraction, but it really doesn't change anything. I can still split this up exactly how I would expect. So I have 12x cubed over 3x plus 15x squared over 3x plus 9x over 3x. So you split it up in exactly the same pattern, and then you focus on each term individually. So here, look carefully. I have x and x cubed, so I'm going to cancel this one x with one of these x's, leaving x squared behind. Okay, let's move on to the next one. I'm going to cancel one of these x's with one of these guys, leaving just simply x behind. And I'm going to cancel this x with this x. That's going to leave no x's behind. Now when I work on this guy, let me change colors, make it a little bit clearer. I'm going to divide this by 3, it's going to make him go away. I'm going to divide this by 3, it's going to give me 4. I'm going to divide this by 3, it's going to make him go away. Divide this by 3, it's going to make this guy 5. I'm going to divide this by 3, it's going to make him go away. Divide this by 3, it's going to make him 3. And on your paper, it's going to look a little bit ugly writing all this stuff down, but ultimately, at the end of the day, you're going to have 4x squared plus 5x plus 3. Everything else has been canceled out. And that's what we say when we talk about simplifying expressions. Break it up. You have to look step by step and just be very careful, because if you miscalculate and make a simple careless error, you're going to get the problem wrong. All right, what if we have 4a cubed minus 8a squared minus 4a, all divided by 4a. So let's go ahead and split this fraction up. 4a cubed over 4a from here, minus from here 8a squared over 4a, so these terms here. Another minus from this guy, 4a over 4a. So now that we have it broken up, we can see what we need to do. Now, working on the end, making it easier, a is going to cancel with a, 4 is going to cancel with 4. So this whole thing reduces to 1 because everything's divided out. Here, one of these a's is going to cancel with one of these a's, leaving 1 left behind. And over here, one of these a's is going to cancel with one of these a's, leaving 2 behind. So we're done with the variables. Now, we divide this by 4, divide this by 4. This is going to give us 2. We divide this by 4, we divide this by 4, so they just go out. So at the end of the day, what I'm going to have here, nothing left here except for a squared. Right? Minus. Nothing left here except for 2a. Nothing left here except for 1, because everything's divided out. So we have a squared minus 2a minus 1. Now, let's do the final problem of this section. What if we have 9 times a squared b minus 3 times a squared b, all divided by 3 times a times b. So let's go ahead and break this guy up. Since it's a big fraction like that, we can do 9a squared b over 3ab minus from here 3a squared b over 3ab. All right, now just remember, take it step by step. So what we have over here, b can cancel with b, 3 can cancel with 3. For a, one of these a's is canceling with only one of these a's, leaving one a left behind. So we're done with that. Over here, b can cancel with b. One of these a's can cancel with one of these a's, leaving one behind. So I strike through the exponent and I leave this alone. Now for the number, divide by 3, gets rid of that. Divide by 3 is going to give me 3. So the only thing I have left is 3 times a minus, the only thing I have left is a, 3a minus a. So the only thing we have left here is we combine the like terms. 3a minus a is 2 times a. Okay, so that's the final problem of the section, and you just need to realize when you're doing this division here, mostly it's an exercise in cancellation of terms. So cancellation of things common to the top and the bottom of the fraction. If you have a giant mega fraction like this divided by something and you want to simplify it, you can always split it up and look at each term separately. But in each individual fraction, you're really looking to see what is common to the top and the bottom. If you have, x squared on the top and x on the bottom, you can only cancel one of those x's because it has to be common to the top and the bottom. If you have numbers, you're going to simplify them just like regular fractions. You're going to divide top and bottom by something, and you'll simplify it that way. So our roadmap is we've done simplifying by adding and subtracting. We've done simplifying when we have multiplication going on. We have simplification when we have division going on. Next section is probably one of the most important sections because we're going to start to talk about what an equation is and solving some simple one-step equations. And you're going to find that you're going to use every skill that we have learned in this entire course to solve a simple equation. But just like learning how to read, you have to learn the alphabet first. Once you learn how to read, then you can write books and stories and do all kinds of nice things. Same thing with algebra. You have the skills now to do some really neat things. So let's go on in the next section, solve some equations, and you'll find that that's not going to be that hard either.